Hello everyone. In this video, we are going to see another problem in power electronics. The question is the input voltage V of t and the current I of t of a converter are given by V of t equal to 300 sine omega t volts. I of t is 10 sine omega t minus pi by 6 plus 2 sine 3 omega t plus pi by 6 plus sine 5 omega t plus pi by 2 ampere, where omega is equal to 2 pi into 50 radian per second. The input power factor of the converter is closest to. Options given are A 0.845, B 0.867, C 0.887, and D 1. So this is a multiple choice question. We need to solve this problem and get the answer and choose the correct option. Since this is a multiple choice question, we have to be very careful while solving this problem, because if we choose wrong option, there will be a negative marking. So need to be very careful in solving this type of questions. The solution of the given problem is given here. We are given voltage expression and the current expression. In the current expression, we have harmonic components, fundamental component, third harmonic and fifth harmonic components are there. We need to find out the power factor. So for finding out the power factor expression can be written as real power by apparent power. And for finding out the real power, we have to take we can find out only the fundamental power, because the fundamental power will be the useful power which will be used for doing the purposeful work. So we need to find out the power factor by using only the fundamental power. So P1 by the apparent power will be the power factor. So for finding out the fundamental power, we need to consider the RMS value of the voltage and the RMS value of the fundamental component of the current, and the angle between the voltage and the fundamental angle between the voltage and the fundamental component of the current we should take. So it is given that 300 sine omega t. So the RMS value of this component will be 300 by root 2. And for the fundamental current, the peak value is given as 10 ampere, and that divided by root 2 will be the RMS value. So, and the angle between the voltage and the fundamental component of the current is minus pi by 6. So cos of angle pi by 6 we need to take. So the fundamental power, real power, will be 300 by root 2 into 10 divided by root 2 into cos of pi by 6. So if we calculate the value, we will get the fundamental power as 1299 watts. And in order to find out the apparent power, we need to get the RMS value of the voltage, which we already know, and we need to get the RMS value of the entire current, including the harmonic components. So which will be square root of 1 by 2, 10 square plus 2 square, which is the peak value of the third harmonic component, plus 1 square, which is the peak value of the fifth harmonic component. So after solving this, we will get the RMS value of the total current as 7.245 ampere. So the total apparent power will be Vrms into Irms, which will be equal to 300 by root 2 into 7.245, which will be equal to 1537.27 volt ampere. This is not volt, this is volt ampere. So the apparent power will be 1537.27 volt ampere. And the power factor will be P1 by S, which is 1299 divided by 1537.27, which will be equal to 0.845. So the correct option is option A, which is 0.845. Thank you.